Uh, so, Rahul, so you have to solve one question,
Okay.
which is uh, you will be given a linked list.
Okay.
You will be given a linked list,
Okay.
and you have to clone this linked list. You have to return the starting point of the clone linked list,
Okay. Okay. Okay.
head pointer of the clone linked list. So the return would be something like return head of clone, clone linked list. So I hope you understood the question.
Yeah. Yeah.
Okay.
So I am given a link. Is it a single linked list or double linked list?
It's a singly linked list.
Wait, it's a single linked list. Okay. Hello.
Yeah. Hello.
Yeah. Okay. So I can assume that I'm given a linked list and I need to. So let's say I'm given a head pointer
Yes.
and I need to clone it. Okay. Okay. So what I can do is, you know, I can keep on traversing every node
Okay.
and I can keep on creating copies of node and keep on returning that, like as a recursive stack. And
Mm-hmm.
whenever I encounter a same node again, that means I'm entering into a loop. That means I am done cloning that linked list. So, so this is a hash map which
No,
tells.
can you explain your logic? Like I didn't get it.
Okay.
So let's suppose it's a single linked list with the structure would be the node. It would be having one data value,
Mm,
and it would be having one next pointer.
okay.
For this, for now, you can assume there is no extra pointer inside the node. This would be kind of a structure. So you have to clone this linked list, and you have to return the head node of that clone linked list.
Okay. Okay. Makes sense. So, is there a any idea also so that I can uniquely identify the node?
Sorry.
Is there some ID so that I can uniquely identify the node, like some? Okay, let's stop that part. Let's just focus on cloning this thing. Okay. So what I'm thinking is I can create a clone function which will take values. Okay. The value will be the head pointer,
Okay.
and I will keep on. So whenever I'm a head pointer, I will clone that node. I will create a copy of that node. Okay, like I will create a node and I will copy the value from the head pointer to my temporary pointer that I have, and I will return that to the parent of basically that recursive uh, re- recursively recursive function that I'm calling. So
Okay.
let me tell you again how I'm going to proceed. So let's say I have a root node, okay, which will basically create the initially it's none. I have a function which is create node which takes a pointer, and what it does is, so basically node is some key value pair where data node is like a hash map where node data is equal to pointer data, okay, and node next is none. I return that node, okay. So that's how I create a copy.
Yeah. Means you are keeping a hash map, something like that, and you are keep pushing the clone of the node inside the hash,
Yes.
right?
Hey, are you able to go down in this screen? Like मेरा 17 से नीचे नहीं जा रहा है यार वो. Scroll हो रहा है ऊपर नीचे.
यस बट इसे ना एंटर करना पड़ेगा, एंटर पे हो रहा है, ऐसे नहीं होगा, स्क्रॉल नहीं होगा, एंटर करना पड़ेगा इसको.
बड़े घटिया सॉफ्टवेयर है यार ये तो. मेरा एक्चुअली जो क्लोन फंक्शन है ना वो गायब हो गया नीचे से यार, क्योंकि मुझे दिख नहीं रहा उसके नीचे वाला वो.
क्लोन तो दिख रहा है, मुझे तो दिख रहा है.
मुझे नहीं दिख रहा यार वो. हाँ अब दिखा. स्लो है काफी. ठीक है. So there's a function which will create a get hash. So let's assume this function returns hash of some. Returns an hash for this particular node. Okay. Right now, I will write the logic for get hash later on. Let's just focus on the clone part first. Okay. So the clone function while true. So I'm entering in a loop. Okay. So first of all, I will create if
just 1 minute. Why you are like considering the loop? Means I didn't even tell you the linked list is having any loop. You can assume it doesn't have any loop.
Yeah. So okay, no issues. Like so, I will assume that it doesn't have any loop. So I'm writing my code. So basically, there will be a clone function which will have a hash map which stores whether the value is hashed or not. Okay. And if head is none, like that means if there is none pointer, then I will return just none, because that means there is no value in the linked list, and I can just exit. I will create my first node. Create node, and I will pass the head to it. Okay. So this will clone the head, that is root of the clone node.
Yeah.
Now what I will do is root dot next is equal to create node head next.
Okay.
And my head will become head next. Okay. Maybe I can take ptr is equal to root, so that I can just, yes. Now I need to increase the ptr will become ptr next. So yes, and if I encounter the if head is none, in that case I need to break from the loop. Over here I will return the root. Okay.
Yeah.
So this is the, like, if there is no loop. Okay. And if there is a loop, that means
I think that's cool. For now you can consider there is no loop. So So what about this value is node visited? I don't think.
I can remove it right now.
Yeah.
Yes.
Yeah, that's a simple code. Yeah, cool. So we'll extend this question, and in addition to the next pointer in the node structure, you will also have a random pointer. Let's suppose random. Okay,
Okay.
and this
Mhm.
random pointer will point to any random node in the linked list. Let's suppose, for example, there is 1 and 4. This is the linked list. Okay.
Okay.
So 1 next is pointing to 2. And let's suppose one as random is pointing to here to 3. Okay. And
Okay.
this 2 random is pointing to 4, right? And this 3 random is pointing to itself. Let's suppose you can assume something like that. So I'll make here something. 3 pointer is pointing to itself. Okay.
Okay.
One random is pointing to 3. 2s random is pointing to 4, and 3s random is pointing to itself, and 4th random is pointing to something you can assume like null. Okay, or none in this case. And now you are asked to return the clone of this linked list. So in the clone linked list, the entire structure should be same. In clone linked list, one is random should point to 3, one is next should point to 2, and in the clone linked list also 2s random would point to 4, and 3s random should point to itself, and 4th random should point to none, means null. So you have to clone this linked list. There is
Okay.
an
So
additional
one solution.
random pointer.
One solution that is coming to my mind is
Okay.
I can just, so there is no loop over here also.
Yeah.
So one thing that I can do is I can just clone it, assuming that it's a normal linked list without random pointer. Okay. After that, I will traverse the list again. Okay. And I will store, so say the original list is 1, 2, 3, 4, and when I am traversing this original list, once random pointer points to 3.
Yeah.
Okay. Now I will store a corresponding mapping. Like if one node in actual list is this, the corresponding one's version in the random list is this, something like that. Okay, hash map, using a hash map. So now similarly, I will have a 3's version in the cloned list. So when I will be at 1, so I will see that once random points to 3, and I will look into that table and will figure out that 3's substitute in the cloned list is say 3 dash, and I will copy that into the once random pointer. So that's how I can proceed.
Can you explain your logic? The given example, how would you create that node?
Okay. So I will be creating clone of first. That will be, let's say it's A. Okay.
Yeah.
Similarly, I will be cloning
1 dash, something like that. That would be very. Just name it 1 dash.
So 1 dash. Okay.
Yeah.
2 dash, 3 dash, and 4 dash. Okay.
Yeah.
Now, so I will store a value in a map. Okay. Which will store corresponding to 1. What is the 1 dash? So I will create a hash of 1.
Okay.
This will be a key, and this will store the address, or you can say object 1 dash. Okay.
Yeah,
Similarly, hash of 2 will store
2 dash.
2 dash.
Okay.
Now, when I'm cloning the random pointer, I will look at this list one. I will say that 1 points to 3. Okay.
Yeah.
I will
One is random.
once random pointer points to 3, I will consult this map list and will figure out that the corresponding version to this is 3 dash. So I will point this value to 3 dash.
Okay.
So that's how I can keep on proceeding.
Yeah, sure. Sure. That looks cool. Can you just modify this clone function so that
Okay.
we can?
So pointer dot random is equal to uh, cloned version and say tmp is equal to head. tmp is equal to head. Okay. So what does this does is I'm like looping over now cloned version. So I have my current template that is pointing towards head. Get hash of tmp. Yes, it will get the hash of tmp. I need to get tmp at hash of tmp dot random. I will get the random node and I'll get the hash on the column. Yes. So this should work actually. Let me just confirm it once. Mm,
Where the
First of all, yeah,
which
I need to
clone?
start. Yeah, just a second. I need to like, create this also.
Yeah.
Cloud version is equal to okay. And when I'm creating this node, okay. What I will do is get hash. Yes. And I need to remove this. Pointer random. Can be random. Yes, this should work.
One thing here is this get has of PTR.
Yes,
Okay, you are using it here and here. Okay,
yes,
and
yes.
every time it is returning a constant.
Yeah, yeah.
string.
I have to modify it. So I can say it like some ptr dot data. Yes, something like that might work.
Let me check once. What you did. You create a node. Okay, let's say it's one dash. Root is pointing to one dash, and temporary is pointing to original list currently, and pointer is one dash.
Mm-hmm.
Okay, while to pointer next, pointer is pointing to the one dash. One dash next would be create node clone version. Version would be empty this time, and it will create a node and you create temporary of next. Temporary would be pointing. Okay, that's cool. Node data, node data, PTR data. Okay, node next none. Clone version of get has of PTR. One is next two. So it would concate. Okay, what will happen if the next is null? Would it be able to stringify it? I think it would be break here because null str.
So so it will. So
It could be like
let me try
these two
this.
values, PTR random, PTR next, could be null. So converting them to the string would lead to exception.
No, actually, it's creating a non string itself. This is working like there won't be an issue over here.
Okay, so what will happen if the string was something like this? Let's say one, one, two, two. How would you identify? Because these two values, let's suppose the first one as random was pointing to somewhere, let's say at 2, and the second one is was the random was pointing to null, and the first one is random was pointing to null, and second one is also was pointing to null. Okay, and let's say only there are two values. Okay, so what will happen
And
when you,
both the values are same.
yeah, both the value are same, so you will get the common string. Means hash function would be the constant for
So in
both.
that case, it will break.
Yeah, in that case it will get break.
So there will be collision in that case. So the idea, like right now, I'm using. I'm assuming that like data is if it's the case that it's same, so we can use like either we can have a ID kind of a inside the node, or we can create a so the Python has inbuilt some object identifier, like you can create the hash of
Mhm.
some something like so Python has a inbuilt function of getting the hash. I need to check whether uh, how does that, maybe something like that I can use.
If you are not allowed to do that, how will you achieve this? Let's suppose you are not allowed to use any inbuilt library.
In that case, okay, so in that case, am I allowed to add a identifier in the node that can
No,
uniquely
no,
identify?
you are not
Or
allowed
maybe
to.
address of the node will be visible, something like it. Can use corresponding map.
You are not allowed to modify the node. Hello.
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 Yeah.
Rahul,
So
your video is not coming. I think voice is clear, but yeah.
yes.
So what I was saying, you were asking whether you are allowed to add any identifier in node or not. So I was saying that this is not allowed. You cannot modify any node.
Brijesh, I guess you can mute me on the code bunk.
Yeah. Is it okay now?
Now I'm still able to hear you. Can you mute your speaker also for the code bunk? Like
Yeah,
going on.
I have muted it.
Hello.
Hello.
No, still double voice is coming.
I have muted.
No, reduce. So there are two options. Like you can mute the speaker also, mute the mic also. Speaker will be visible on my profile picture.
Yeah. That I have disabled.
Let me reload it then. Hello.
Hello.
Right now there is no doubling noise.
Okay.
Let me get back to this. Hello.
Yeah. Is it okay
Yeah.
now?
It's okay.
Okay. Sure.
So in that case, it won't work. Like if data is same,
Yeah.
my hash function will break.
Yeah. Sure.
So one solution I have is I can create a ID. If I'm not allowed to create an ID, so I can get the object address. So something like that is there, no? So say this is a map, okay? Map to let me Python getting the. Basically, what I'm trying to use is, see, every node, although it has same value, it will be an object, okay?
Yeah.
That object has to have a unique ID stored in the memory. So maybe I can use that memory to identify the duplicacy. So that will be always unique.
Yeah. So don't you think that the PTR would be always unique? It's a address.
Yeah, PTR address will always be unique. So so I need to just check that. So I was not very clear with the syntax, like how can you convert that address to some string or something like that. So that's why I just added this part.
Okay. So what is the point of get hash if you are returning the pointer itself?
No. So I don't know how to convert into something like that is there. Okay. I don't remember exactly. So basically, you can create a unique hash of based on the object pointer basically itself. So I need to figure that part out. So I was unaware, so I just created a function. Something like that.
So I don't you think you are complicating these things? Means I don't think there is a need of this hash. Means you can still achieve your goal without this hash function. Can you think about this? How you will achieve?
Okay. So when I'm like on the cloned version, so you mean like, so what I can do is I can make the one dash points toward the three. Okay, so if I do like I just keep the same value in the random pointer, then they will point towards the original list. Now I need to somehow replace them by 3 dash. So I'm at 1. Okay.
So I'll suggest write it down on a paper. You'll get a better clarity. So just write it down on a paper. You'll get a break. Rahul,
Yeah, yeah.
think about it. I'm coming within 2 minutes.
Sure. One dash points toward 2 dash. This points toward 3 dash. Points toward 4 dash. So when I will creating like one dash clone, it will point towards 2 dash. This will point towards 2. Its random is pointing toward the 3. So what I can do is its next will always be valid. Random will point towards the 3. Random will point towards. I can clone the whatever is inside the one in this. So one random is pointing towards 3. How can I make sure that? So one is pointing towards 3 now. As somehow I need to make sure that it points toward the. So Brijesh, can I modify the original list?
No, you are not allowed.
Okay. So so I'm so what I'm trying to think is
Hmm.
using next it makes sense. Like you can always get the whole list. But for the random pointer, you need to somehow need a reference to the cloned value. If you can
Yeah.
eliminate
So,
that part, that will be that
Rahul,
will like yeah.
uh, the first you had write a clone function.
Hmm.
You had written that the first time when we were discussing. That would be the first part. Means like cloning the entire list without a random pointer. That
Yes,
what you know how to do. Okay. So only one part is left.
with random
Attaching the
pointer
random pointer.
without
Sure.
using hash map.
No, you can still use hashmap.
Okay.
So think about this. For updating the random pointer, use the hashmap. There is two process. First is already done. You can write two functions. The first one would clone the entire list without the random, and the second part would update the random pointer in the clone linked list. So for that part, you can use the hashmap. And now think about it. How would you use hashmap to update the random pointer in the clone linked list? You have already cloned the linked list without the random pointer. Okay. Only one part is left, updating the random pointer, attaching the random pointer in the clone linked list. And that you can achieve with the hashmap.
Okay. So right now I'm using hash map and I'm getting the hash corresponding to the actual list. What is the node in the cloned list? And after getting that, I'm putting it in the random point of the cloned list.
Yeah. So one thing I'll correct here. You don't even need this get hash. Look it in the create node function. So what will happen? For one, think about if the linked list was 1 2 3 4. Okay. So for one, you will have a one dash in the map. Key would be one here, PTR, and node is considered as a one dash. It's a clone linked list. Okay,
Okay.
right? So you don't even need this. So I
Okay.
am
Got it. Got
giving
it.
you.
Yeah.
Okay.
You are right.
So
Hash I don't need. Makes sense.
okay. So what you are having in the map is corresponding to one you are having one dash, corresponding to two you are having two dash,
Two dash.
three
Yeah.
three dash, four four dash. And now
Yeah.
using this map, how would you update the random?
So okay. Uh, there's another way. What I am. So what I will do. I will just
Mhm.
store the random pointer value to the value that's there in the old list.
Sorry, how?
Okay, so you know what I can do? If PTR is in the cloned version, like if the node is already cloned, so I can in that case I can just put node random as um, cloned version. Otherwise, I just don't need this anymore now.
Yeah, yeah, you can remove that. And think
Yes,
there is an issue. Think about this function. There is an still an issue
just a
in
second.
updating the random. There is only minor mistake.
Just a second. Let me just complete this. So pointer pointer random is equal to mm, cloned version of Pointer random is in clone version. So yes. Otherwise, node random is equal to pointer random. And the problem with this will be if pointer random is not in the key. Oh, yeah, this all yeah, makes sense. Hmm. I will be looping right now. Basically, you know what? This is not required. You can just store. Trying to be too ambitious over here. Now when I'm traversing this list, the pointer random will be pointer random. Yes, that should work.
Okay. Where it will point? Rahul?
Yeah.
Where it will point? In clone linked list or original linked list?
So this will point towards the original link.
Yeah, but that's we don't want. Clone should
Yeah.
point to clone list.
So when we'll be in the loop 51, okay. So we'll make sure that pointer random points to the cloned version.
Sorry.
When like in the line 51, we'll loop through the list again.
I got it. So where you are de-attaching this pointer? Still, it's point to the original list, but we don't want that. It's a
No.
dynamic pointer pointing to.
So
Are you
no,
getting my point?
so whatever I've understood is after create node function, okay, the cloned linked list is pointing towards the original linked list, especially in the random pointer, only in the random pointer case. But we want random pointers to points towards the cloned corresponding cloned node.
Yeah,
Okay.
that means the cloning a linked list means you
Yeah.
don't have to point the original linked list. You have to just create the same clone of the original. So for random, so clone random should point in the clone linked list, not in the
Clone,
original. Yeah.
So
Here is the issue.
So I'm trying to tackle that problem in the loop in the line number 51. So what is happening is I'm like it's an infinite loop. So while I'm traversing the list, okay.
Okay.
So currently it will point towards the root node. I will pick the random version of that. That random will point towards the old linked list corresponding random version. I will from there I will get the cloned version object ID, and that I will replace it to the pointer random. So that's how I can just keep on progressing forward. So basically this loop will make sure that all the random pointers are replaced by the corresponding cloned pointers.
But still you in the clone version, look, this map clone version, it is still this still is having the original node, original random. Look, what is you are doing here? Node random, you are pointing to the original random. Okay, so you can say one was there, one you created one dash. Okay, so one dash random is pointing to the one. Are you getting my point? One dash here, one dash 1 dash random is pointing to the one random,
Yeah.
1 is random, right?
That is towards 3. 1 dash is pointing towards 3. Yeah.
Yeah. So okay. So basically, what is happening? 1 dash random is pointing to the 3, not 3 dash.
Yeah, 3. Yeah.
Yeah, 3.
After
It's
after
pointing,
the create node, after the create node part. Exactly.
yeah, definitely. And here, what you are doing? Pointer random. It's a pointer is, I think, it's a clone. Means 1 dash
Yeah,
random.
it's a
Here,
clone.
1 dash random is going to point 1 dash random, but 1 dash random was pointing to the 3, not 3 dash. This is the
Yeah,
problem.
exactly. So
Yeah.
we will have
Still the
3.
same problem exists. Still in the code, same problem is there.
Okay. So see, this will points toward 3 pointer random. In my case, pointer random will point towards 3.
Yeah, definitely 3.
So in the cloned version, 3 will have corresponding 3 dash.
No, it's not happening. That's why I'm saying it's not having the 3 dash. It's not
No,
having the 3 dash.
okay.
You are
In line number 32, I'm like making sure that cloned version is basically a key map from the old list to the new corresponding new list. So
Mhm. So think about it. What in this code? What happens? 1 dash is pointing to, sorry, 1 is pointing to 1 dash. Means 1 is a key and 1 dash is a clone in map. Okay, right?
yes,
Okay, you got it.
yes,
And every time what you are doing, every clone random is pointing to the original's corresponding random. Means 1s random is pointing to the 3 in the given example, not 3 dash. Okay,
yes.
and here you are saying that you will get 3 dash, but you won't. How?
Uh, so when I will be creating a cloned version for the 3, it will have 3 dash.
Yeah, but you are not sure that's random. There could be duplication.
I'm unable to get actually the point. Can you like elaborate with an example?
Let me think once. Yeah, yeah, Rahul, it will work. I think it should work.
Okay.
It should work. Okay.
So the complexity of this will be around like ON.
Yeah, and
Space complexity is again
ON.
ON.
Yeah. Okay. So I think it would work. The code should work. That's not this one.
Okay.
Okay. Cool. Cool. That would work. And Okay, so space complexity would be order of n. So what if I say uh, you don't have to use space, you have to do in order of n time? How will you do it? You just have to tell me the algorithm. You don't need to write the code.
So you mean like I cannot use extra space?
Yeah.
Okay, so what I'm thinking is, say this is the case, like 1, 2, 3, 4. When I will start with 1, I will create the node. I will, um, and now I have to go and create the next also random also. I will, if I will go using random, I will go to 3.
Yeah.
Okay. Uh, when I go to 3, I will see that like if somehow I can get the mapping or I can store the mapping,
So where you would you store? You would you
like
use the same list?
no, maybe wait. I'm having this cloned version. No, why when I'm using cloned version? Uh,
Because of this, you need
if I
to
can,
update.
yeah, if I can just modify the exi, am I still allowed to modify the existing? Am I
Yeah,
still not allowed to?
yeah. You are allowed to modify the existing uh, linked list, but you have to revert it back after getting the clone.
Oh, okay. Uh, so say I have one. I will create one dash corresponding to it. Its next will point. Its random will point to 1. Let's do this. Hmm. 1 dash random is pointing towards the actual one. So 2 dash random is pointing towards the 2. 3 dash is pointing towards the 3. Now I need to go to 3 dash. I need to go to 3. So once random will say go to 3. 1 dash random will right now is pointing towards 1. When I will be cloning the random pointer in the actual list, once random is pointing towards 3. So if somehow I can store 3 dash at this place, that will be a good thing. So what I can do is okay. So one solution that is coming to my mind is
Mm-hmm.
uh, I will modify the existing linked list
Okay,
when
how?
when I'm cloning it. So what I
Mm-hmm.
will do is I will make sure that random points towards the random of the original linked list points towards the corresponding cloned value. Okay,
Okay. So
and the random of the actual list and random of the cloned list will points towards the initial value in the original list. So for example,
mm-hmm.
one dash random will points towards 3. Okay,
Okay. Okay.
but once random will points toward 1 dash.
One
So
is once random would point to, sorry, once rand once random is going once random is going to point 3. Okay.
initially.
Initially, okay. And
So but I will modify it in such a way that 1
mm-hmm.
dash random is going to points toward 3. 1 dash.
Okay. Okay.
I can
Got it.
copy that. Okay,
Yeah. Yeah.
and once random is points toward 1 dash.
So it would point to 3.
Yes, 1 dash random is point.
It's still pointing. I mean, you don't have
Yeah,
to modify it. It's still pointing.
yeah. So I have that mapping right now. Now I will iterate over the list again. So when I will go towards 1 dash, okay,
Mm-hmm.
1 dash will say go towards 3.
Okay. That's
Now, okay, from
Mhm.
3 is
Mhm.
random. I can get 3 dash pointer.
good. Yeah. Yeah.
I will update 1 dash 2 points toward 3 dash.
Okay.
Now I will go back to the 1 because I am iterating like those lists simultaneously. I
Mhm.
will go toward the 1. Now
Mhm.
I will copy the ones random
Mhm.
to 1 dash random. Like before updating the 1 dash random, I will copy that value into 1 random.
Mm.
No, but there's an issue with this. The issue is if some other pointer is pointing toward 1, now I won't get 1 dash back. So basically, I need this mapping to get towards the. Okay, so so the way this is helping me in the clone list part is
I'll give you a hint. Think about around it. Do it something like that. Let's suppose the initial list was 1, 2, 3, 4. Okay.
Mhm.
So you create one list, create one node. Okay. And attach within 1 and 2, 1 dash. So the linked list would be 1 next put point to 1 dash, and 1 dash next point to 2. Write it down. 1,
Okay, okay.
1 next point to 1 dash. You have just created and inserted in between these two nodes 1 dash,
Okay.
and 1 dash next is pointing to 2. And again same for all the nodes. 2 next would point to 2 dash, and 2 dash next would point to 3. Do like that.
Oh, you mean like whenever I'm doing next, I can just copy.
Yeah.
Oh yeah, that makes sense. So I got it now. So you know what I will do is
Mm-hmm.
in the original list, okay,
Okay.
I will add a corresponding duplicate link just into the next. So once
Yeah.
next will point to one text and all this thing. Now
Mm-hmm.
once I'm done with this list, okay,
Mm-hmm.
I will update the 1 dash random pointer.
Yeah. How?
Uh,
How? There is a catch. How
yeah.
would you apply?
So even right now, 1 dash random pointer is pointing towards 3 right now because I'm
Yeah.
cloning it. So I will just go one step ahead and take 3 dash and I will put it into the
No, no,
my
no.
original.
One S dash random is not pointing to any one. The clone linked list is all the random of clone linked list is pointing to null, because
So the way I will clone it I will clone the list in such a way that after one, whenever I'm inserting 1 dash, even
Mhm.
the 1 dash random is pointing towards the original random.
Why would you means like point? You can point in the second iteration. Like why you are pointing to the
Uh,
original thing? Why not point to the 3 dash? How would you point to the 3 dash?
yeah.
After
So
creating this node, after creating this first step, how would you in the second step, how would you point one is random to the 3 dash, not
yeah.
3?
So when I'm like doing the traversal again, okay,
Mm-hmm.
I will come at 1 dash.
Mm-hmm.
I will know that its random is pointing towards 3 because of the initial calculation.
Uh-huh.
Now I will go next in the 3 dash, in the 3, which will give me 3 dash. So I will update 3 dash over there.
Yeah, that's the case. What you'll do, you'll go 1s random next. 1s
1 is
random
random.
would give the 3 dash.
Yeah,
So
3
this is
dash.
how you will update the random. And
Now,
you'll keep traversing in this way for all the node.
and I can I can separate these two linked list also
Yeah,
because they are like fixed
yeah,
pattern. Yeah,
that's a simple case. Okay.
yeah, makes sense, makes sense.
Okay, so we are done with the first question.